Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation. So let's get going. Problem solve x square root of 1 minus x square y square minus y into dy plus x plus y into square root of 1 minus x square y square into dx equals to 0. Given differential equation, x into square root of 1 minus x square y square minus y into dy plus x plus y into square root of 1 minus x square y square into dx equals to 0. We can write this as x plus y into square root of 1 minus x square y square into dx plus x into square root of 1 minus x square y square minus y into dy equal to 0. Consider as equation number 1, which is of m dx plus n dy equal to 0 form. Where m equal to x plus y into square root of 1 minus x square y square and n equal to x into square root of 1 minus x square y square minus y. Now we'll check whether the given differential equation is exact or not. So if the partial derivative of m with respect to y is equals to partial derivative of n with respect to x, then we can say that the given differential equation or equation 1 is exact. Okay, let's now find the partial derivatives of m and n. We'll begin with partial derivative of m with respect to y. Dou y of m, x plus y into square root of 1 minus x square y square. We can write this as dou y of x plus partial derivative of second term, dou y of y into square root of 1 minus x square y square, right? Since we know that partial derivative, it is a partial derivative with respect to y, right? We need to find partial derivative of a term with respect to y. So we'll treat the remaining terms or remaining variables as constant. So here x is treated as constant and partial derivative of a constant with respect to y is 0. Okay? Plus partial derivative of, here we are having product of two terms, right? We need to find derivative of product of two terms. So we'll apply uv dash formula, which is u dash v plus v dash u. So we'll get partial derivative of y with respect to y into square root of 1 minus x square y square plus partial derivative of square root of 1 minus x square y square into y. This is equals to partial derivative of y with respect to y is 1 into square root of 1 minus x square y square plus partial derivative of, or we know the derivative of root x is 1 by 2 root x, right? So first we'll apply this formula and later we'll find inner derivative. Okay, so we need to find, we'll get 1 by 2 into square root of 1 minus x square y square into partial derivative of 1 minus x square y square into y. This gives us square root of 1 minus x square y square plus 1 by 2 root 1 minus x square y square into partial derivative of 1 with respect to y is 0 minus partial derivative of, or we can go for one more step. We can write this as dou y of 1 minus dou y of x square y square into y. This gives us square root of 1 minus x square y square plus 1 by 2 root 1 minus x square y square into partial derivative of 1 with respect to y is 0 minus, since it is partial derivative with respect to y, so x square is treated as constant. We can write this term as x square into partial derivative of y square with respect to y. Okay. Into y. This gives us square root of 1 minus x square y square plus 1 by 2 root 1 minus x square y square into minus x square into derivative of y square with respect to y is 2y into y. Right? This gives us square root of 1 minus x square y square plus into minus 2x square y into y square, that is 2x square y square by 2 root 1 minus x square y square. Here 2 gets cancelled and you'll get square root of 1 minus x square y square minus x square y square by square root of 1 minus x square y square. Therefore, partial derivative of m with respect to y equal to square root of 1 minus x square y square minus x square y square by square root of 1 minus x square y square. Let's now find partial derivative of n with respect to x. Dou by dou x of n. x square root of 1 minus x square y square minus y. This equals to partial derivative of first term minus partial derivative of second term. So here we are having product of two terms, right? We need to find partial derivative of this term with respect to x using uv dash formula, which is u dash v plus v dash u. This gives us partial derivative of x with respect to x into square root of 1 minus x square y square plus partial derivative of square root of 1 minus x square y square into x minus partial derivative of constant with respect to x. Since it is a partial derivative with respect to x, so y is treated as constant. Then partial derivative of y, that is a constant, with respect to x gives us 0. This is equals to partial derivative of x with respect to x is 1 into square root of 1 minus x square y square plus partial derivative, since we know that derivative of root x is 1 by 2 root x. So consider 1 minus x square y square as one term. So we'll get partial derivative of, the derivative of square root of 1 minus x square is 1 by square root of 2 into square root of 1 minus x square y square into partial derivative of inner function into x. Right? This gives us square root of 1 minus x square y square plus 1 by 2 into square root of 1 minus x square y square into partial derivative of 1 with respect to x minus partial derivative of x square y square into x. This gives us square root of 1 minus x square y square plus 1 by 2 root 1 minus x square y square into partial derivative of constant with respect to x is 0 minus, here is a partial derivative with respect to x, so y is treated as constant, so y square is constant here, so we can write this term as y square into dou by dou x of x square. Okay, into x. This gives us square root of 1 minus x square y square plus 1 by 2 square root of 1 minus x square y square into minus y square into partial derivative of x square with respect to x is 2x into x. This gives us square root of 1 minus x square y square plus 1 by 2 into square root of 1 minus x square y square into minus 2 x into x square into y square, which is equals to square root of 1 minus x square y square plus into minus 2 x square y square by 2 into square root of 1 minus x square y square. Here 2 gets cancelled and you'll get square root of 1 minus x square y square minus x square y square by square root of 1 minus x square y square. Therefore, partial derivative of n with respect to x is square root of 1 minus x square y square minus x square y square by square root of 1 minus x square y square. Now observe partial derivatives. From this we can say that dou m by dou y equal to dou n by dou x. Sorry, it's not y, it's x. Equal to square root of 1 minus x square y square minus x square y square by square root of 1 minus x square y square. It shows that the given differential equation is exact. Therefore, partial derivative of m with respect to y equal to partial derivative of n with respect to x equal to square root of 1 minus x square y square minus x square y square by square root of 1 minus x square y square. Therefore, 1 is exact, or the given differential equation is exact. Okay, now we need to find the general solution to the given equation. Since the given differential equation is exact, so the general solution is given by integral m dx treating y as constant plus integral n terms of n free from x into dy equal to c. So let's now integral separately. These two integrals separately. So I'm going to begin with integral m dx treating y as constant. This equals to integral m x plus y into square root of 1 minus x square y square into dx. Here y is constant, right? This is equals to integral x dx plus integral y into square root of 1 minus x square y square into dx, where y is constant. So in the integrand of second integral, we are having y into square root of 1 minus x square y square, right? We can write this as, see here we can take this constant y square outside the square root. For that purpose, what I'll do is, here you are having 1, right? We can write 1 as y square by y square minus x square y square is equals to y into square root of, now take y square common from these two terms, we'll get y square of 1 by y square minus x square, right? This equals to y into, now split square root of y square into 1 minus y square, 1 by y square minus x square as square root of y square into square root of 1 by y square minus x square. Here y square is constant again. This is equals to y into square root of y square equal to y square. Since we know the square root of a can be written as a power 1 by 2, so we can write square root of y square as y square power 1 by 2, which is y. Right? You'll get y into square root of 1 by y square minus x square. This gives us y square into square root of 1 by y square minus x square. Now replace the integrand by y square into square root of 1 minus y square, 1 by y square minus x square. Then this becomes integral. This equals to integral x dx, treating y as constant, plus integral, we can replace this integrand by y square into square root of 1 by y square minus x square into dx. Now write this constant outside the integral. This equals to integral x dx is x square by 2 plus y square into integral square root of 1 by y square minus x square into dx. Since we know that integral square root of a square minus x square into dx equals to x by 2 square root of a square minus x square plus a square by 2 into sine inverse x by a plus c. Then for a square equal to 1 by x square, sorry, it's y square, right? For a square equal to 1 by y square, and for a equal to 1 by y, we'll get integral a square minus x square can be replaced by, just apply the formula here, okay? X by 2 into square root of a square x square, that is 1 by y square minus x square plus a square by 2, or we can write it as 1 by 2 into a square, that is 1 by y square into sine inverse x by a. Okay, this gives us x square by 2 plus y square into x by 2 square root of 1 minus y square minus x square plus 1 by 2y square into sine inverse x by 1 by y equal to xy by 1, right? So you'll get xy. This becomes x square by 2 plus xy square by 2 into square root of 1 minus y square minus x square plus y square into 1 by 2y square is y square by 2y square into sine inverse xy. So here y square gets cancelled. This is equals to x square by 2 plus x by 2 into, we can write y square as y into y plus 1 by 2 sine inverse xy. So I am going to take y square inside the square root simply by replacing 1y by square root of y square. Since we know that square root of y square is y, so we can replace 1y with square root of y square, so that we can take y square inside the square root. This is equals to x square by 2 plus x by or xy by 2 into, I'll replace this y by square root of y square into square root of 1 minus y square minus x square plus 1 by 2 sine inverse of xy, right? Which gives us x square by 2 plus xy by 2 into, now we can combine these two, we'll get y square into 1 by y square minus x square plus 1 by 2 into sine inverse xy is equals to x square by 2 plus xy by 2 into square root of y square into 1 by y square minus x square y square plus 1 by 2 sine inverse xy. So here y square gets cancelled and you'll get square root of 1 minus x square y square. This is equals to x square by 2 plus xy by 2 into square root of 1 minus x square y square plus 1 by 2 sine inverse of xy. Therefore, integral m dx treating y as constant is equals to x square by 2 plus xy by 2 into square root of 1 minus x square y square plus 1 by 2 sine inverse xy. Now coming to the second one, integral n terms of n free from x into dy. So now observe n. We have n equal to x into square root of 1 minus x square y square minus y. So the terms of n which are free from x is minus y. So we'll take only minus y here. Okay, is equals to minus integral y dy, which is equals to minus integral y dy is y square by 2. Now coming to the general solution. The general solution is given by integral m dx treating y as constant plus integral n, that is terms of n free from x into y equal to c. Then result obtained from the first integral is x square by 2 plus xy by 2 into square root of 1 minus x square y square plus 1 by 2 sine inverse xy plus result obtained from the second integral is minus y square by 2 equal to c, or x square by 2 plus xy by 2 into square root of 1 minus x square y square plus 1 by 2 sine inverse of xy minus y square by 2 equal to c. Or we can write this as x square by 2 minus y square by 2 plus xy by 2 into square root of 1 minus x square y square plus 1 by 2 into sine inverse xy equal to c. Now take 1 by 2 common from all these terms, that is the terms of LHS. Will get 1 by 2 times x square minus y square plus xy into square root of 1 minus x square y square plus sine inverse xy equal to c. Now take this 2 to RHS, will get x square minus y square plus xy into square root of 1 minus x square y square plus sine inverse of xy equal to 2c. Let 2c equals to some constant, say capital C or some k or something. Since c is arbitrary constant, 2 is constant, so you can write 2c as a constant, some c or k or something. Then we'll get y square, x square minus y square plus xy into square root of 1 minus x square y square plus sine inverse of xy equal to some c, or if you want to write it as some k, you'll get k. Okay, x square minus y square plus x y into square root of x square 1 minus x square y square plus sine inverse of xy equal to k. is the required solution. So we have seen a problem from exact equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.